Section 5.5. This time we're doing triple integrals, but not in rectangular coordinates, cylindrical and spherical. So first, let's get to know how to work in these coordinates. Cylindrical coordinates are similar to rectangular coordinates, except for the xy plane has been replaced with the r theta polar plane. So the same thing that we used when we did polar coordinates, we will use that instead of the xy plane. So to plot a point in cylindrical coordinates, you still use an ordered triple, but instead of x, y, z, you have r theta z. So to plot that, you would rotate your radius just like you did in polar coordinates, find that point in the polar plane, and then from there, go vertical for the value of z. We have our translation equations here to translate between x, y, and z. So let's practice doing that. If we have a point that's given to us in cylindrical, so 4, 2 pi over 3, negative 2, we're told that's a cylindrical point, and we would like to translate it into a rectangular point, which means we need to find x, we need to find y, and we need to find z. We know that x is r cosine theta, so from our cylindrical point, we can see r is 4, theta is 2 pi over 3, z is negative 2. To calculate x, we do r cosine theta, or 4 cosine 2 pi over 3. Cosine of 2 pi over 3 is negative 1/2, so we end up with negative 2 for x. Y is 4 sine theta, or 4 sine 2 pi over 3. Sine 2 pi over 3 is root 3 over 2, so we have 4 times root 3 over 2, or 2 root 3 for y. And z, with cylindrical polar coordinates, z is exactly the same as the z in rectangular, so we just get to copy over the negative 2. So the point 4, 2 pi over 3, negative 2 from cylindrical coordinates is exactly equal to the point negative 2, 2 root 3, negative 2 in rectangular. Let's try that again. So this next point, we know it's cylindrical, so we have our r value, we have theta, we have z. To calculate x, we take r times cosine theta. To calculate y, we have sine theta. Type those into our calculators. We get 5 times root 3 over 2. That doesn't simplify, so I'll just write it 5 root 3 over 2. And then sine of pi over 6 is 1/2. So we have 5 times 1/2 is 5 over 2. And z copies right over. So the 5 pi over 6, 4, becomes 5 root 3 over 2, 5 over 2, 4. If we were to swap the direction, say that we start with a rectangular point and we translate into cylindrical coordinates, we don't use the exact same equations. They do derive from the same relationships, but if we know x, y's, and z's, then we're going to want to plug those into a function to calculate r theta. So we start off by identifying that we have x is 1, y is negative 3, and z is 5. To calculate r, we use the relationship r squared equals x squared plus y squared. So we have 1 plus 9, or 10. So if r squared equals 10, then r equals the square root of 10. We need to find theta. Theta is y over, tangent theta is equal to y over x. In other words, theta is going to be tangent inverse of y over x. Now with tangent, we have to be careful because there are two solutions to tangent inverse within the complete rotation of 0 to 2 pi. So if we know that y is negative, then we know that we're going to be to the left of our x-axis, and we know that x is positive, so we're going to be in the front of our y-axis. So if we were talking about quadrants, we would end up in quadrant 4. So we want to make sure that the theta that we get puts us in quadrant 4. If we do tangent inverse of -3, we find an angle of -1.25 approximately. And that's straight out of the calculator. But there's a problem here because -1.25 is outside of the range for the theta that we use in polar coordinates. Theta should be between 0 and 2 pi. We don't like to talk about theta in terms of negative values when we are describing polar coordinates. So instead of using -1.25, we're going to find a coterminal angle by adding 2 pi to that. And if we add 2 pi to the -1.25, we get about 5.03. So the theta that we'll use is 5.03, and the z, of course, just copies over. So the rectangular version of this point is then √10, 5.03, and 5 for z. Well, let's try another one. We have x is -8, y is +8, z is -7. So we start by calculating r. R squared is equal to -8 squared plus +8 squared. That's 64 plus 64, or 128 for r squared, which means r is equal to the square root of that. Which is 8√2, according to the handy-dandy calculator. And then we need to find theta, so we'll let theta be tangent inverse of 8 over -8. Now if y is positive, then we know that we are on the right side of the x-axis. If x is negative, we're behind the y-axis, so we are approximately in quadrant 2. So we want to make sure our theta gives us the appropriate value there. So we're looking at tangent inverse essentially of -1, which gives us another negative angle. We get out 0.79 approximately in radians. And again, we want theta to be between 0 and 2 pi, so we're going to add 2 pi to that to find the angle that is coterminal with it at 5.49 radians. So our rectangular version of this point becomes 8√2 for r, 5.49 for theta, and -7 for z.